So, good morning. In our today's class, we'll continue with the mathematical physics. That is basics in vectors in IIT Foundation. In today's class, we are going to learn about types of vector. Till now, we came to know about vectors. What is that? Size of the vector, I mean magnitude of the vector, in plane, along the x-axis, along the y-axis, or in a space, and how to convert that normal vector into a unit vector. In today's class, we are going to know about some types of vectors. Look, I'll give you headings. Everyone, please note it down. Okay, everyone, from F star to F3, all students. Like vectors, opposite vectors, unlike vectors, equal vectors, co-initial vectors, co-linear vectors, unit vector, zero vector, or null vector. Here, what are like vectors? Like vectors, when they are in a straight line, look, this is a sign of a vector when I am writing on a blackboard. This is not a vector, and this is not a vector, and this is not a vector. They are different shapes in mathematics, but they are not called vectors. Only this notation, drawing line like this, is a notation of vector. So how to write like vectors? Here I drawn a vector. The name of this vector is A bar. Now I am going to draw a like vector. A like vector. Look, this is a like vector. This is another vector. B is a like vector of A bar. Even the size of vector B is different from size of vector A. We are calling these are like vectors. These are like vectors. Observe this. Unlike vectors. This vector. Okay. Noted? Unlike vector. Look. Observe this. What is the gap left between these two? Here and here. Compare. When I drawn this B vector B, is it like vector A? No. Even the size and the direction, observe the direction. And distance also from A to B. And here also from A to B. How it is? Are they same? No. You can take these two as an example for unlike vectors. And now I'll draw this one. A small change here. Look how they are. Vector B is how they are. The gap left between these two is the same as that of gap between these two here. At every point, at each and every point, the distance between these two is the same. They are anti-parallel vectors and like vectors. Anti-parallel vectors and like vectors. Anti-parallel. Look, suppose if I am taking vector A like this, and vector B. Look, what is the gap left between these two here? Is it not same the gap left between these two here? Same only. These two also. Observe here. The gap left between these two here. Anywhere is the same. But observe the direction here. Are they in same direction? No. They are not in same direction. Are they in same direction? Yes. They are in same direction. We are calling these two are anti-parallel vectors and they are parallel vectors. They may call also unlike vectors and they may call also like vectors. Okay. equal vectors. Observe the sizes. This may be when you are measuring this may be up to 20 centimeters. Observe here, this is also up to 20 centimeters will be. Then we are calling these two are equal vectors. Suppose the same A 20 centimeters is drawn here, and this is a B. And what is the size of these two vectors? Are they parallel? Yes, they are parallel. Are they equal in magnitude? No, they are not equal in magnitude. They are unequal vectors. Unequal vectors or unlike vectors you will get. Look, next, come on to these two. Co-initial vector, co-linear vector. Observe these two. Are they co-linear? How can I say? If they are acting along the same axis and drawn like this. 1 and 2. This is A bar and this is a B bar. We can say these two are collinear vectors. Here one more is missing. Coplanar vectors. What about these two and these two and these two and these two? Are they drawn on this blackboard? What are they? Coplanar. Are they drawn on blackboard? Yes, they all are drawn on blackboard. Observe this pair, these two pair, this pair and this pair. They are drawn on blackboard. Okay, they are drawn on blackboard. They are not in different planes. This blackboard, suppose you are taking this blackboard is in XY plane. Already in our previous classes we discussed about plane. This is x-axis and this is y-axis. The space covered between these two axes is called XY plane. In XY plane only vector A and B are drawn. If vector A is like this in this way and vector B is in this way, then you can say they are not in same plane. But here all are the pair of these two, A and B, all are drawn on this blackboard only, and it is in a XY plane. So all these pairs are said to be coplanar vectors. Okay, plane lo unnatlu. They are in same plane. What about collinear? Already I told. If they are following the same line in this way, we can say collinear. Now, co-initial vectors. Here, this is vector A, and this is the starting location, and this is vector B. If both are starting at same point, we are calling this is a co-initial vector. Initial, starting. When they both are starting at one point, we are calling these two are said to be a co-initial vector. Look, unit vector. Already we know this. In our previous classes we studied about this. Unit vector. The vector whose magnitude is equal to unit. Unit means once. Only one. The vector whose magnitude is equal to 1 is called a unit vector. And come on to the zero or null vector. The vector whose magnitude is equals to 0, we are calling that vector as a null vector or zero vector. Okay. Now we can add or subtract these vectors. By taking an example of force acting on a block. After subtraction or after addition, we are giving the name as a resultant. For example, our first problem here. Suppose you are taking a block. This is a block, massive block. massive block, and you are applying force on this. You are applying force on this. Along x-axis you are applying. Along x-axis you are applying. Suppose a force acting like this. Force acting on this block like this. You can say this force is acting along y-axis in upwards direction. In upward direction. Force acting along y-axis. This is force acting along x-axis. Force acting along y-axis and force acting along x-axis. Suppose, what is the force acting along x-axis? Observe here how I am writing. This is the magnitude. You can write like this. F. Magnitude of force. Observe what I am saying. This is nothing but magnitude of force. These two lines, these two vertical lines gives you information that you are given a magnitude of vector. A magnitude of vector along x-axis. Along x-axis. Can I write like this? Yes, I can write like this. Ilagoda write. This is along x-axis. How much I am giving? How much I am giving? Magnitude no. 25 newtons of force. 25 newtons of force is acting along x-axis. What about the force acting on y-axis? Force acting on y-axis. Along y-axis. Along y-axis. Along y-axis. Magnitude of force along y-axis. F along y-axis is equals to 0 Newton. So here this force vector is a 0 vector. No force is acting along y-axis. Only force acting along x-axis, that is equals to 25 newtons. 25 Newton. 25 newtons. So what is the net force acting on this? Net force is acting on this is equals to 25 newtons along x-axis. Along x-axis. This is how we came to know in which direction the force is acting. Suppose here one more force is acting. One more force is acting along x-axis. Look. Along x-axis. Can I take this as a F1 and can I take this as a F2? Two forces are acting on this. Two forces are acting on this. How? One is acting here, second one is acting here. F2 is equal to 19 or 10 newtons. 10 newtons. What is the net force acting on this? Net force acting on this. You are given magnitude of vectors. Observe this. In which direction it is? It is along x-axis. It is also along x-axis. It is also along x-axis. But he given on right hand side of the block. No problem with that. So you can write like this. F net is equal to F1 plus F2. F1 plus F2. Sum of these two is equal to 25 plus 10 is equal to 35 newtons. Fn is equal to 35 newtons. This is the net force acting on this block. Just note it down. Suppose if F2 is acting opposite to this one, how can you write your net force? Your force is acting 25 newtons on x-axis and another force is acting opposite to direction of that. Opposite. You can take here for F2 as a negative symbol. Opposite. Along the negative x direction, one more force is acting. Just subtract these two. To get the net force, subtract these two. 25 Newton minus 10 Newton. How much it is? 15 Newton. This is your net force acting on this block when the two forces are acting opposite to each other. In tomorrow's class, we will proceed with a little bit trigonometry to get the resultant. Okay, ma. Bye. Note it down.